so again, this is a presentation I put together with Sonali McDermott, who many of you know as the AgMIP resource person for the Southern India team. But Sonali is also now the co-leader of the AgMIP climate team. So she's involved not just in that team's activities, but in putting together the tools and approaches for all the activities. And she'll be helping around the workshop with everybody here. All right, so the overview of what I'll talk about today is we'll start with the basic approach for AgMIP Phase 2 in Sub-Saharan Africa and South Asia. Really, this is going to come about in the approach that AgMIP Climate has tried to take for all AgMIP projects, which is to have a focus first on the current period climate, then an understanding of the sensitivity of agricultural production to climate changes, and then finally going into that future period climate scenario. And in all of this, the AgMIP climate team is going to be collaborating on agroclimatic analysis to understand how this climate information affects the crops and how we can interpret the scenarios and the results of all this work. So you'll see a little bit of all of this here. So the design of Phase 2 is also going to be slightly different from Phase 1 in the sense that it really begins with this projected benefit of a decision for stakeholders. So we've designed this project to be oriented around stakeholders having questions about what the future will look like and wondering how actions they take today will create a more resilient future. So we want to understand, our goal of our project is to understand the projected benefit of a decision for stakeholders. To understand that, we often have to begin with economic analysis because this tells us the units of currency and the decision making is often done on an economic basis. But to get the economic understanding of how a system will respond, whether a decision is made or not, we need the agricultural impact of climate change and adaptation. And of course, we can't understand that agricultural impact of climate change if we don't have the climate change itself. So we come at the bottom of this, the climate people on this call come at the bottom of this chain, which is kind of the input data that drives a lot of this analysis. But don't judge yourself or don't judge me or anybody here based on where you fall in this chain. All of these are crucial elements that link together to get to the analysis that we need. To understand this, this is not just a climate people pass information to the crop modelers and then walk away. This is the stakeholders are interested in talking to all of the experts. They'll have questions that regard all elements of this modeling and data chain here. So we have to be prepared, even on the climate side, to interact with the stakeholders and the stakeholder liaisons from each of our teams. To actually have this information that gets up to the stakeholders, there is this kind of data chain, and the climate people are responsible at the bottom here for providing probabilistic climate change scenarios and current period climate so that the agricultural modelers can go from there. And you'll see also an input to the agricultural models is some of the adaptation packages that will be simulated. But where you see the light blue words on here, that's code, meaning that this is what the climate people will provide. And even when you get to the very top, there's another place where climate people come into the analysis, which is that the economists are going to end up with results from several different climate scenarios, and we need to provide information about which of those climate scenarios is more likely. So this probabilistic climate shift at the top here, this is in reference to the idea that we will be assigning weights and probabilities to various climate scenarios in the end. This is kind of how, in some ways, how Phase 1 was done, which is this passing of information and scenarios and data and outputs from model to model. What we didn't emphasize enough in Phase 1 was the other side of this chart, which is the analysis. And you can see in gray here that the major analyses provide context and credibility to what we need to do in this project. So it's no longer enough to just provide a climate scenario, hand it over, and be done. We have to understand how the climate is changing. We have to understand how the system is responding to those climate changes, and we have to have an ability to say what our model is doing well and what our model is doing poorly. So to do that on the climate side, we have to have a strong quality control and quality assessment of the current period climate data. We have to do a good job of analyzing the historical climate trends. We're going to do a lot more analysis of the current variability. This is not just to understand how our system responds to climate, but also to lend the credibility of the model by saying, you know, these crop models that we're projecting out to the future do an adequate job of picking up major climate events in the last 10, 30 years. So we're going to do a lot of work looking at how the historical period, the 1980 to 2010, what we call current period, understanding how that climate affects the interannual variability of yields. So for example, we would see if the current farming system was very sensitive to drought or to heat waves, or maybe it's to drought at anthesis, or some combination of climate and agricultural properties. The final thing here is that we're going to do this probabilistic assessment of future CTW projections. Now we're starting to get into the acronyms here. You're going to see this a lot. CTW stands for carbon, temperature, and water. The idea being these are the major climate change components that we want to understand how our system responds to. Now you'll also see this kind of CTW projections. We're going to talk a lot about how we interact with the crop and the livestock modeling team in terms of understanding that. And maybe you can skim ahead if you want here and see what the crop model and economists are doing, but they also have a set of analyses that they are undertaking to provide the context and the credibility of all of these models. And then, of course, this purple box in general is new, which is that we have a devoted group of people who are engaging with stakeholders, and you'll see some of their activities here as well. And if you want to learn more about that, you can watch the Stakeholder Units webinar from a couple weeks ago, and I believe are next up next week. They have their second webinar. But some more about this, the analyses related to carbon, temperature, and water, and you'll see that's nitrogen. So if we want to understand the basic farm system response, we have to understand how it responds to carbon dioxide changes, changing temperature, changing water or rainfall, and changing nitrogen levels. And the reason that gets mixed in as well is that there's a lot of evidence that, you know, the way a plant responds to carbon dioxide depends partially on whether there's nitrogen stress. And likewise, interactions between temperature and water can come into play. In the CTWN analyses, we are going to be looking in particular at three main tasks. The first one is, as I was just discussing, we're going to look at climate variability along with the crop and the livestock team. So we're going to look at simulated crop yields from 1980 to 2009 and try to understand how that interannual variation in yield is linked to interannual variation in climate. That will allow us to hopefully identify the climate metrics that are driving interannual variation in yield, and also hopefully allow stakeholders to recognize major events in the recent past and hopefully have a strong model simulation of those events. So again, we're not expecting every single wiggle in the historical climate to be perfectly simulated, but if stakeholders talk to their, if the stakeholder liaison talks to the stakeholders and everybody in a region is remembering a major drought in 2003 that devastated the yields, hopefully our simulations are able to capture that. The second task is looking at this carbon, temperature, water, and nitrogen sensitivity, where now we're not looking at pure historical data. What we're doing is we're running simple sensitivity tests that allow us to test how the system responds in particular to each of these changes. And this is going to be done on, I actually have a whole slide on this a little bit later, but we're going to do this looking at temperature, rainfall, and CO2 and nitrogen individually and in combination using various methods that have been established across lots of AgMIP projects. And then finally, the third task is this carbon, temperature, and water uncertainty in the climate projections. And this will be just the climate team. I have a slide on this later, But the idea here is that we know we can't run every single climate model through all the crop and livestock and economic simulations. So it falls on the climate team to understand how the models that we do select represent that broader uncertainty. Because of course the range of carbon, temperature, water, and nitrogen tests that we'll look at is much broader than the actual projections of where the GCM say climate will go for any given region. So we'll be looking at that CTW uncertainty in climate projections, and that will also allow us potentially to go into the realm of other time periods and scenarios from things like the regional climate models. All right, let's see. I'm going fairly fast here, and I'm hoping we can do this whole presentation in about an hour. But if you have questions, feel free to put them in the chat, and then we'll have questions anytime throughout the call, or at the end we can have a short discussion as well. All right, so when we're thinking about putting all of this together and meeting that need for stakeholders, I find it quite useful to use an exercise here, which I've laid out at the top. So imagine that a stakeholder asks you or the regional research team how a particular adaptation will benefit a region in the future. The challenge here is that that future will be affected by climate change, but also by economic development and the adaptation itself. So if we want to understand what's happening, we can't throw everything together because it will be very hard to separate. So what we've done here is we've created these 4 core questions for integrated assessment that will help us to separate and understand these various factors. So the questions end up being these 4 here, which you'll see are similar to what we had in phase 1. And I'll go through these in more detail after I summarize them here. So the first question is, what is the sensitivity of the current agricultural production system to climate change? The second focuses on the effect of adaptation that could be applied even today in the current climate. The third question looks at the impact of climate change given a future agricultural production system that has developed through economic and other forms of development. And then finally, what is the benefit of adaptation in that future climate change and future economic system? So that fourth question kind of puts all of the pieces together. But by building it up like this, as you'll see in a moment, this allows us to really understand what's happening and give stakeholders the full picture. So for core question 1, this is the question, what is the sensitivity of current agricultural production systems to climate change? And this question really determines the vulnerability of the current system, and at some level is a way of knocking out of complacency stakeholders who may be ignoring this problem. So if we have a current farming system and the climate changes, in many cases you'll see vulnerability just because of warmer temperatures and things like that. So this gives us the very basic idea that climate change could potentially be a challenge for the future. And what you'll see here from a climate perspective is all we're doing is we're comparing the climate of today to the climate of the future. Nothing else is changing. So this is almost a climate change sensitivity test. And you'll see on this chart here, I maybe should describe this since we're going to use it for a couple. What you see on this left thing where it says current S1, that S stands for system 1. This is the current technology. So this is the farm system as it currently stands, using the cultivars and the planting dates and the farm equipment and the access to irrigation. And then on the economic side, the current households and job opportunities and labor costs and all those things. That's the current system. On the right is the future system, where those things may have changed. You could have overall higher incomes. Labor would demand higher payment. You may have more access to equipment. All of these other things, the economists and the stakeholders and the crop modelers are working on what that future technological and economic system will look like. So this first question goes from this blue dot, which we're going to call these each of these dots systems themselves. So this is the blue system, our current period, and when we compare it to a different system, which is where climate change has occurred, that's what this orange dot is here. So this difference between the current climate and the future climate, that's what we're trying to measure with this first core question. All right, The second core question takes that same blue dot representing current and says, well, what if climate change didn't occur at all? What if all that we did was the adaptation? Would this adaptation be beneficial? And hopefully it would be beneficial. So here we're taking this blue system and comparing it to one where we use the same climate and the same agricultural and economic system, except for just this adaptation that we're trying to test. And that gets us to this pink system, and we can measure the benefit of that adaptation in the current system. And there's some overlap here. The crop modelers don't have to rerun this blue system. It will be the same. We've tried to design this to be to prevent redundancies and things like that. All right, the third core question now ventures into this future period. So we have this dashed line, which has this wave on it, which is just our way of saying we're not exactly sure how we get from today to the future. But what we're trying to do is estimate what that future production system will look like. And that's going to depend largely on the agricultural development. And for the sake of this understanding, we have tried to separate the economic development from adaptation and climate change, or adaptation to climate change, maybe I should say. So this is looking purely at that economic development side. That brings us from the blue dot, which was current everything, up to this black dot, which is what would the future look like if all that happened was agricultural development. Then once we're in that future system, now we can apply climate change on that future system and measure the impact. And in many cases, you'll find a different impact because of the way that the households are structured and the way the equipment is used, and other technologies will have a different future impact of climate change. The fourth question now kind of puts it all together, which is says, let's look at what the benefit of adaptation is, given that future technology, given climate change. And this allows us to understand the benefit in its full context of that adaptation. Now remember, all of this has come back to a stakeholder who asked, what is the benefit of this adaptation? And now we're able to say, putting it all together here with these four current questions, we're able to say, well, climate change is a threat, potentially, in question one. The adaptation would have some benefit, potentially, in the current period. But then when we go into the future, we see that climate change's threat has changed, and the benefit of that adaptation has also become slightly different than what it would have been today. So putting this all together, we're able to say the impacts of climate change, economic development, and adaptation, and give the stakeholder that full context. And there's a lot of interesting things I'm sure you can imagine, measuring the benefit of the adaptation today and comparing that to the benefit of the adaptation in the future. If the adaptation were just as good today as it is in the future, then that's what we call a no regrets adaptation. There's no reason to justify that adaptation with climate change. It's just something that we should do. So that's the type of thing we're able to now compare with this core question 2, which is the one that was not in our previous phase 1 work. Now, again, I know that there may be some people on this call who have not been exposed to what we were doing in phase 1, and this may be a little bit complicated. But what I would encourage you to do is go back to these slides, hopefully listen to my discussion a couple more times, and try to get a grasp of this, because this is not a technical challenge in terms of writing an Excel application or anything like that. This is the conceptual basis of what we're trying to do here in terms of understanding how climate change and adaptation and economic development will affect a region in a way that allows stakeholders to begin to make decisions and allows our models to support those decisions with the best information that we can provide. So this is the kind of thing, we'll probably go through this several more times. We'll go through this again in Victoria Falls. But I'd encourage everybody to think about this, because this will allow a much closer engagement with the project as a whole. All right, so that was the overall context. Now I'm going to dive a little bit more into what the climate team itself is doing. And the climate team is somewhat fortunate because we really have a fairly simple set of tasks, in the sense that we are basically tasked with coming up with the best possible data set for the current period climate, and then making scenarios of future climate change. And if we were doing just a climate change study, and I'm sure people on this phone call have done just climate change studies, we could do much more complex analyses and scenario generation. In all likelihood, we would use many more GCMs, we'd use regional climate models, statistical approaches, and many more things like that. The task that we have before us, however, is not just a climate analysis. It's to connect into the crops and into the economics, and to do this across a whole range of farm sites from an economic survey. And when you add up all of the combinations of adaptations and crop models and economic simulations, this becomes a very large number of simulations, and an even more intimidating number when you realize that it's not just running the models, we have to analyze them. So in phase one, we had very strong and at times heated negotiations over how many climate change scenarios we would do. And I'm sure you could imagine my role in those arguments was always to push for more and more and more. And where we ended up compromising was in this future climate change, we will have a test site where we will look at more than 20 different GCMs. And however, when we go all the way to all the farm sites and pass the information through the whole process to the economists and eventually to the stakeholders, that will be a subset of just 5 GCMs. All right, and we have also narrowed it down to look at the mid-century climate, which is 2040 to 2069, and we will be using just one set of methodology, which in this phase is going to be the mean and variability scripts that we explored in phase one, but this is now front and center for phase two. And we'll talk more about that in a little bit. All right, so I see a question or a comment from Carolyn. Carolyn, let me just make sure. Yeah, so Carolyn made a comment. I'm not sure everybody could see it. It might just be a private comment here, so I'll read it carefully. But it's you know, the key point that she wanted to make here is that stakeholders really are already making decisions, and in too many cases their decisions ignore the longer-term climate change perspective. So we're trying to help them make climate-informed decision across several different timescales and to integrate the kind of thinking about climate change into their broader framework. And the best way we can do that is with evidence and analyses that demonstrate how our tools are ready for this kind of longer term perspective. I see also a comment from Olivier, slide 11. Let me make sure I know which slide. Yeah, this is slide 11. The 5 GCMs identical for all or location dependent? The answer, Olivier, is that they're now location dependent. In the last phase, they were the same for all locations. In this phase, they will be the same for each economic survey. So what I mean by that is, let's say you have 120 sites in Namibia that you're looking at. All 120 sites would have the same GCMs so that we could do economic analysis consistently. But the sites that you have in Namibia may be different than the sites that the CLIP team uses in Botswana. I'm sorry, the GCMs that you use in Namibia may be different than the GCMs that are used in Botswana. So I actually have a whole slide on that in a little bit, and you'll see how we propose to decide which 5 you use. All right, so that's the overview of the climate, and maybe I'll just jump back a slide, and I'm going to ask Sherry, since she's quick on this usually, can you see my mouse, which I'm using as a pointer? Anybody? Yes. Okay, thank you, Sherry. All right, so I'm just going to very quickly point to these so you get an idea. If you'll recall, the difference between the blue and the orange dot was climate change, and the difference between the black and the red dot was climate change. So you'll start to get an idea that for each of these blue, pink, black, green, all of these dots, there is a specific set of climate information that's needed. And we've summarized that here. And there's information here for climate and crop and economists, but for the climate people on this call, all we really need to do is look at this column here. And it tells you for each of these systems what climate is needed. And you can see it's either the current or the CC, standing for climate change, for each of these systems, and this is kind of your go-to lookup table if people are asking for information. This is the climate information that's needed. All right, so that's the kind of overall context and the way the climate information is going to fit into this. I'm going to run through some of the basic approaches that we're taking, and many people will recognize several of these approaches from phase one. And then just for your information, in the next webinar, we're going to focus more on analyses. So here we're talking about the general idea of the methodology, and in the next webinar we will focus on how to do the specific analyses in terms of understanding, how climate is affecting various systems. And some of that will be new. So for those who are experienced in this, bear with me. You might see some new things. And for those who are new on the call, feel free to follow up if you have questions about this. And there's a handbook that we're putting together with these protocols written out that will help. All right, so maybe I'll jump back here. So the first thing here is we're looking at the historical climate data. How are we going to get historical climate data to design our future sessions? Now, somebody who just joined, could you please mute your microphone? Because right now we're hearing feedback. Thank you. Great. So how are we going to get this historical climate data? The primary source of historical climate data is going to come from station observations. If you can find a nearby station, that is the gold standard for our assessments. That's what we really want, is a good local observation, because there really aren't any global products that can top good station observations. However, in our experience and in phase one, we found that even some of the very best sites, not just in Africa and South Asia, but even the United States and other places, even the best sites have gaps, they have problems. And in that sense, our approach is to find the very best station data and then do extensive quality assessment, quality control. And our kind of backup for when there is a gap or a segment of the observations that we don't trust, our backup is this AgMERRA historical climate data set, which you can access in terms of full maps at this link at the bottom here. But if you want just a single location, what you need to do is send me an email giving me the name of that location and the latitude, longitude, and an estimate of the elevation. And if you really don't know the elevation, you can just say missing. But then what I can do is I can pull this time series and send it to you. And what you see here is a bunch of plots, which is probably more information than you need. But the basic idea is we've created this AgMERRA data set and compared it to a bunch of other data sets that do similar things. And we are quite pleased to see that it has reduced maximum and minimum temperature biases. It has a very strong correlation. This dark blue line is a strong correlation for rainfall. And these blue lines here show that it does a good job of capturing rain events, not just when rain occurs, but also kind of moderate and heavy rain events. It does quite well compared to other data sets. If you want to learn more about this, there's a paper on AgMERRA, which is published in Agricultural and Forest Meteorology. You can let me know, and I can send a copy of that along. But the general idea is AgMERRA has this improved solar radiation, improved precipitation variability, does some fine spatial patterns using satellites. It has an adjustment for a diurnal temperature range, and it provides relative humidity at maximum temperature. So if anybody is using more complex models that need that, I'm not sure about InfoCrop, what exactly is needed. I know that the IGV team is trying to use InfoCrop, but we should have all of the variables that are needed for your crop modelers and your livestock needs. And the other thing that is new compared to phase one is that we now have a tool that you can use. It's an Excel spreadsheet template that if you have your observational data, you can paste it into that template and it will very quickly convert into the AgMIP data format, which then it becomes perfectly parallel in terms of format with what AgMERRA provides. So again, this is the basic idea is we're going to do some quality assessment, quality control, and we'll fill in gaps using AgMERRA. And next week we'll talk a little bit more about actually doing this because, or sorry, the next webinar, we'll talk more about actually doing this, and hopefully coming into that webinar, some people will have their data on hand so that we can actually try it with real data. What we do after we calibrate a good observational site in or very close to our farm survey, what we then do is we attempt to estimate the climate at each farm location. And to do that, we use a data set called WorldClim, which is really just a monthly data set. It tells us, the average temperature in any given location in May or in June. It doesn't give us the full daily data, but what we can do is we can take that local observational site and realize that where that measurement was taken tends to be, let's say, 1 degree warmer than a farm site nearby. And we can use WorldClim to understand that it has that 1 degree warming compared to the other site. So then when we're estimating what the climate is at that farm site, we take our observations and we subtract a degree in that month. So it's a very basic approach that allows us to add some fine spatial resolution and understand how various farms might be different from each other just based on simple patterns of climate. And often what we'll see more than anything, and actually what you see here on the left is AgMERRA. You can see the kind of spatial resolution here. And then the WorldClim you can see has much better texture and detail. So just to use, again, South India as a region, some of these plateaus and valleys that don't show up in AgMERRA, we're able to capture by using WorldClim. And that's really the idea of projecting out to regional farms. And so this is going to be one of the things we're going to be challenged to do. We have a methodology by which we do that, and I'll show you that again in a minute. But just to understand the challenge, we're trying to get climate at individual farms so that, as we're understanding the distribution of yields across various farmers, we can understand how local climate comes into play. The other thing that I really want to encourage everybody on this phase from the climate team is to engage with the stakeholders and the stakeholder liaisons on your team to understand a little bit more about how the region has a sense of climate when it comes to agriculture. And just here are some example questions of that. When and why do farmers plant when they do? Some of it may be due to economic or other limitations, but other times it is basically a rule of thumb from climate. And it would be very nice if all of our kind of future reports were able to talk about the context of the climate and how it actually is, the rules of thumb can show great variation across different regions and across different crops. The other thing is, what climate events, what climate, what types of climate are associated with a bad harvest. So I'm sure if we did surveys of all of the regions and came to one of our big workshops, we would find that there are regions where everything is drought limited, and there are other regions where things might be solar radiation limited, or might be, due to high temperatures. That's the big problem is heat waves and spikes of warmer temperatures. So understanding that would be quite interesting. In regions like West Africa and South Asia, I think it would be very interesting to think about how the monsoon is characterized. What do people consider the beginning of the monsoon period? What do they consider a break in the monsoon? In some cases, a break in the monsoon is just a meteorological term. It might be 2 or 3 days with no rainfall. In other places, it's probably thought more of as things like a period long enough that water stress starts to begin occurring in the plants. If we can start to get a feel for rules of thumb of how people think about the monsoon, we will be able to provide much better advice of how the monsoon may be changing in the future so that we can adapt and prepare for that. And then finally, what are the major concerns regarding climate change? Having conversations with stakeholders. What are you worried about? What are you trying to offset? What are you hearing from your constituents or from the farmers in your union? What is it that you're worried about? Because we can check that. All right. So as we have our historical climate data and quality control that, the next step is to go looking at how crops respond to these core climate change factors. And what we're going to do in phase 2 is set up 2 different sets of sensitivity tests. The first one is a very simple linear set. So this will be, for example, temperature sensitivity test where nothing is changing except for mean temperature, and we'll go from -2 to 8 degrees Celsius. Just very simple linear tests of temperature response. We'll do that again for rainfall. We'll do it for CO2. We'll do it for nitrogen, and we have some cross checks where CO2 and nitrogen are changing simultaneously. And these are things where probably the climate people don't even need to help in terms of designing this. These are tools that can be done within the crop models. Often you can just adjust mean temperature. But I really want the climate people to pay attention and follow along with this, because understanding those responses is going to help us understand how the climate scenarios are to be designed and interpreted. In addition to those linear sets, there's also going to be the C3MP set. That's an acronym again. In AgMIP, we have a project called the Coordinated Climate Crop Modeling Project, C3MP. And this is a project now with more than 1,100 different simulation sets from around the world, covering 50-something countries, 20 crop models, 16 crop species, and all of them have done the same set of sensitivity tests. And these end up being 99 sensitivity tests that cover these ranges of temperature from -1 to 8 degrees Celsius, of rainfall from -50 to +50% changes in rainfall, and carbon dioxide concentrations going from 330 up to 900 parts per million. Once we've done those sensitivity tests, we can create impact response surfaces and understand where the vulnerabilities and where the sensitivities of the crop models are. And here's just an example of this. This comes from a paper that I published. It's in Global Change Biology. And this demonstrated this methodology and this protocol using a site in Alabama. I've shown this to many people, so hopefully it's a little bit of a review. But this type of response surface where we're able to see, in this case, that hotter and drier conditions are the most detrimental, but we also see interesting effects. For example, as we get out to the hottest temperatures, this is 5, 6, 7, 8 degrees warmer, you can see that we start to have very diminished returns to rainfall. It doesn't really matter how much rainfall we get because the temperature response is so dominant. So this type of understanding how crops respond also allows us to then look at the GCMs themselves, because these tell us where the climate is actually heading. So it's one thing to understand where the vulnerabilities are. The next step, and this is where the climate team plays a crucial role, the next step is to see whether the climate is changing and putting us into a more vulnerable state. So in this case, what you see here are GCMs projected in green for the near term, in yellows and browns for the mid-century, and in reds for the end of the century. And these are showing that strong temperature increases and uncertain rainfall increases, which if you plot back onto this chart, put us in squarely into this brown range. And of course, the third dimension not seen here is carbon dioxide. And when we look at carbon dioxide versus temperature for various different sites, this is corn or maize, rice, winter wheat, soybean, other crops, you can see they all have different shapes in terms of their basic response to temperature and CO2. So we need to understand from the crop modelers how the crops respond, and then the climate people are able to plot on top of these and understand where the climate is actually expected to go. So this is going to be some more analysis. I think you'll find that it is very, very useful. It's a little bit of a methodological jump and kind of getting your head around how to make these response services and what exactly they are, and we will show you the methodology of it. But once we have this and an understanding of how to utilize them, it really is helpful in terms of understanding why the crop models are responding as they are, and providing that information to the economists so that we can say why scenario A is different than scenario B in terms of the potential impact for stakeholders. Okay, so once we have those sensitivity tests and have that confidence in understanding how climate uncertainties affect the crop models and the response of the agricultural systems, we can now go into the climate scenarios for integrated assessment, this is where we start to put it all together and say, what are the actual GCMs showing us? And I think people have seen these before. The top two plots here are the median temperature change and the median precipitation change from 20 different GCMs in CMIP 5 from RCP 8.5. I believe this is the end of the century. All right, I'll have to double check on that. It's either the middle of the century or the end of the century. And understanding these patterns is certainly useful, but what you have to realize when you look at the median, when you look at the average across many GCMs, you end up blurring together many individual systems that don't quite make sense when everything is just averaged together. So you can look at this and see, you know, drying over the Mediterranean and wetter conditions in parts of the monsoon here. But individual models within this are also plausible explanations of the future. And it's in our interest and in the stakeholders' interest for us to understand the variation, which is why at the bottom here we look at things like the standard deviation, the spread of temperature changes, and the proportion of models that agree on wetter or drier conditions. You can see very rarely do all 20 models say it's getting wetter or getting drier. There's uncertainty here that we have to understand. Now, all of these tools, I've alluded to several in both the historical and the climate sensitivity side as well. A lot of the analysis that we've done is possible using a set of R programming language scripts that we created in phase 1 that produce these climate scenarios and several analyses using this kind of freely available R programming language, the scripts that we've made, and then data sets that we have provided with information about GCM projections. So I attached this guide to the email I sent out just before the call, and you can use that. It also has, I also attached a zip file with the R scripts that, you know, the latest versions that I have. I am working right now with Sonali and some colleagues here to update those. And by update, I don't mean change the actual methodology as much as we are adding additional GCMs. So in the past, we had 20 GCMs. That number originally was determined by the number of GCMs that were available at the time we were beginning phase 1. Of course, that number has gone up. So I would expect we're going to have somewhere between, you know, 25 to 30 GCMs for this next phase. So what we will be doing is we'll be adding more data and scripts that allow us to look at more GCMs. So you'll see that in the coming weeks. But in the meantime, I don't think it's a cause to delay. Everything that we're doing is the same methodology, and if you can get comfortable with this R script and this R guide, then you will be able to very quickly replace anything that you do with the updated GCM. So it will be a much faster interaction if you've gotten started on this. And the whole idea of this R guide, I have huge amount of thanks and gratitude for Nick Hudson, who is somebody who I worked with, who made this R guide to. Well, it's, you know, step-by-step instructions with screen guides and kind of evaluation data sets to make sure you're getting the same numbers we got. So please, you know, download this, try it out. Let me know if you're stuck or need data, and we will get through this. But you know, the nice thing about it for the climate team is many of the scripts, if you follow the instructions, you can complete 90% of the work. And that ends up being the technical side. And then really what I'm excited about in phase 2 is having the technical side hopefully a little bit easier will free up all of the expertise on this call to do the analysis, which is, I think, what all of us enjoy the most. And that will also, I think, help the climate team better integrate with the rest of AgMIP regional research teams to make sure that our insights go all the way through to the stakeholders and final reports. All right, so I see a question from Subhash. And I'm not sure, let's see, I'm just skimming it. Some people are sending me private messages. I want to make sure I'm not doing anything. It looks to me, Subhash is saying in general that since stakeholders are concerned about extreme climate events, we should do some analysis for this as well. There has been damage to wheat in much of the Indo-Gangetic Plain this year due to unseasonal rainfall during the reproductive stage of wheat. So this is a kind of real-time example of climate extremes affecting crops. This is an interesting idea. I think as we do analysis of the historical variability and start to identify what climate metrics are affecting crops, if we find some kind of a seasonal impact, or sorry, a subseasonal impact from extreme events, it would be interesting to design sensitivity tests around that as well. That is something we can do, and I'd be very happy to work with that. Now, I see Asan has also said the same thing in Pakistan. There's been unusual rains affecting the crop. So this is something that, again, I'm very pleased to hear this, or obviously I'm not pleased to hear that it's actually happening, but this type of insight, this type of analysis is something we can definitely pursue. And if there's something that you're hearing from your stakeholders or from your own thoughts is something we should be doing, let's talk about it. Let's talk about it before Victoria Falls, because we might be able to design sensitivity tests that allow us to explore that in the best possible way. All right, so, and here you can see at the bottom, there's also additional tools getting the time series into standardized formats. One of the things about these R guides is it works best if everybody can get things into the same format, because then the program is ready to go. All right, so what we end up looking at in terms of the future, this type of figure made its way into many of the final reports and chapters from phase 1. But what we want to be able to do is show how the current climate is changing, both on temperature and rainfall levels. So what we have here is the months from January, February, March, all the way to December. This is an example from Japan. You can see it's not from these regional teams. And the black line with the asterisks, or the stars here, represents the current climate. And this just comes from the historical data set that we calibrated. And then the future is this gray band of uncertainty. So the GCMs, you can see, are predicting warmer temperatures across all months. And in this case, it's a pretty narrow band all the way across. So the uncertainty is not that large compared to the seasonal cycle. And there's uniformity in terms of the direction of change. It's always warmer. When we look at rainfall, again, we have these black line and stars, and you can see there's not much agreement in terms of the GCM projections. Some of them are saying wetter conditions, some of them are saying drier. The median projections, which are the red lines, you can see are often quite close to the current, with the exception in this case of July, where it seems to be some pretty strong agreement in the GCMs that it will be wetter in the kind of height of the monsoon rains reaching Japan. But that's interestingly countered the next month by slightly drier conditions. So understanding this and being able to present this in the final reports is really helpful for stakeholders, just to emphasize the warming signal is quite robust. The rainfall signal is not as strong. But having this for each region, especially if there is a strong signal in a certain season, would be worth understanding. Now, this is in response to what Olivier discussed earlier about how are we going to select these 5 GCMs. In the past, we dictated it from on high with the theory that we would eventually connect all of the regional teams, and therefore we needed to have the same GCM across all the regional teams. In retrospect, we realized that that was slightly premature, in the sense that we are not yet doing large, continent and multi-continent scale analyses using these results. So that's something we're discussing in other aspects of AgMIP. But for this time, what we're going to do is we're going to pick 5 GCMs that represent the type of projections that we see across the wider, full, 20-plus GCM ensemble. So let me explain how exactly we're going to do that. This is a scatter plot of, in this case, annual. You'll see all of the months listed here. This is annual precipitation change as a percent of current and annual temperature change in degrees Celsius. And I put a black box here representing today's conditions. So you can see this is, 0 temperature change and 100% of today's rainfall. And this is a site in France that we were looking at for AgMIP's grasslands and livestock team. And what we've done here is we've divided these 20 GCMs, we've plotted them all on this chart with the letter representing which GCM it is. Just, you'll see here A through T, representing 20 different GCMs. And then what we did is we took the median temperature change and that's this dashed line, and the median rainfall change, which is this dashed line. And we've divided this into 5 different quadrants. I know it's not quite a quadrant if there's not 4 of them, but 5 different sections, let's say. We have the hot and wet quadrant. We have the cool and wet quadrant. We have cool and dry, and we have hot and dry. And then we have the middle, which is within a half of a standard deviation of both the median temperature and rainfall. And when we divide this all up, we see actually that there's 6 models that fall under the hot and wet. There's 6 models that fall under the cool and dry. There's 3 models that fall in the middle. And then this direction is less common, which is the hot and dry. There's only 3 here, and cool and wet, there's only 2. So in this location, what we would do is we would pick a GCM from each of these sections, and we would run that all the way through our economic analysis. And then in the end, we would weight them according to these numbers. So the hot and wet GCM is going to be represented with a weight of 6, whereas the cool and wet will be represented only with a weight of 2. So it's still worth understanding for stakeholders, but we are able to acknowledge that this is a less common projection. And then what you see here is the dot represents the average of all of these hot and wet. So this kind of yellowy brown dot here represents the average of all of these hot and wet models. And you can see it's quite close to this O model. So that would be our recommendation for the GCM that you would use for the hot and wet quadrant at this location in France. And likewise, you can see it looks to me like the K model probably best represents the hot and dry. Maybe this F model best represents the cool and dry. And then either the S or the H would be a suitable choice for the cool and wet. And then maybe T or B within the middle. So the idea, again, is we would show this plot in our report to justify our selection of our 5 GCMs and the weights of our final results, and we go from there. So how does this sound to people? I think this is a new idea. I would argue that it is a more transparent and defensible way of picking our 5 GCMs that will allow us to better represent the overall ensemble. And if we could put this in a paper with 2 or 3 paragraphs to justify it, I think it would be very sufficient for reviewers. So not seeing any objection to that and realizing we're getting towards the end, I'm going to keep going. We can talk about this more in email, and for those who are in Victoria Falls, we can discuss this in great detail. And I see Seydu saying this looks like a pretty good idea. Okay, good. All right, so we're getting very close to the end. I just wanted to put this very quickly. This is in that R guide that we sent around. And what it does is it shows how we've done climate codes for scenarios. I would just encourage the climate team members to look at this and try to understand this code because it's going to be seen throughout the AgMIP project. The IT tools that have been developed by Cheryl Porter and her team are utilizing this code. In several of the final reports that I saw from phase 1, you saw things like the CAXA scenario, which wouldn't make any sense, but if you had this code, you would know that there it is right there, and that's telling us a specific time period, scenario, GCM, and scenario generation methodology. So you can see that in the code as we go forward. So I encourage everybody to start to understand that. The R programming language guide and all the scripts in there also utilize this code. So it will help you understand what you're actually getting. Now, Sherry sent me a message reminding me that 11 o'clock is not a hard stop, 11 o'clock in New York, that is. So if people are able to stay on for a couple more minutes, I'm going to keep going. I'd estimate another 10, 15 minutes. But if you do have to run, I understand. I think I only have one more slide, which is this homework slide. These are things that I really hope that we can do. And what my little code again here, when you see this little arrow here, that's something that I hope you'll be able to do in the next several weeks so that at the next webinar, you'll be able to give some feedback as to how this is going. And we can start to do analysis with real data in the next webinar. Where you see a dash, that's maybe more ambitious. If you're able to get to those things, that would be great. But I understand if that might be more than a couple weeks away. So in general, I really strongly encourage everybody who has not already installed the R scripts. If you're going to be making climate scenarios for this project, please make sure you have the R scripts installed. Utilize that guide. Try to understand it. Do some practice. We gave you some test climate, so utilize that. Make some scenarios, for Ames, Iowa, just because that's the test provided. And ideally, you do this on a machine that you can bring to Victoria Falls, because I really do want to have a workshop in Victoria Falls where we are working with the actual data and the scripts themselves, because that will help us get much further. In the historical period, I'd encourage the climate team leaders from each regional team to work with the PI to make sure that as soon as possible you identify the regions that we're going to study, and get an idea of the name of that region and its approximate location. Then get the best local weather station you can for that location, with an emphasis especially on maximum minimum temperatures and rainfall. Here I said precip for precipitation. And then download that AgMIP format template for historical observations so you can convert it to that format. And if you haven't already, send me a request. I'll send you the AgMERRA data so you can start to do this quality control to fill in gaps and create that master historical period file in the AgMIP format. So then if you can, also talk with the PI about whether the farm sites have been identified. If there's an economic survey, the economists are trying to make sure that all those data are identified as soon as possible. If you're an economist on the line, this is another reason to do it, is the climate people need that information to start to build the climate data for each of the farm sites. So if you can identify those farm sites, you can run the farm climate script in the R package to estimate the historical climate series using this master historical period file. And then the other thing that I would encourage you all to do, in the email I sent out before this call, I also included, in addition to the guide, an addendum which is focused in particular on a script called AgMIP to metrics. And Sherry, I'm going to call you on this. I don't think it's yet been converted to a PDF and posted online, so I would encourage you, if you can, to find time to do that. I'll work with you on that. But at the very least, it's attached in a document, Word document format to the email. And that AgMIP to metrics script will allow you to take any .agmip file and look at very specific climate metrics. So for example, you could look up days of excessive rainfall in early May and give it a threshold, let's say above 50 millimeters per day in early May. How often has that occurred in any year in the last 30 years? You could look that up using the script. And then you can make your future climate scenario and look at all those climate scenarios and see if that event is becoming more common. That's the kind of thing you can do with AgMIP to metrics. In terms of the sensitivity tests for homework, I encourage everybody to read this paper that I wrote, Ruane et al. 2014. It's the C3MP overview paper. Probably right after this call, I'll attach it to the listserv. This is the basic description of how we do this impact response surface and the sensitivity test using that Alabama example. Please read that. It will help you understand how the whole process works. Somebody who just came on, please mute your phone. We're hearing some echoes. Thank you. In terms of the future period, again, I'm not sure everybody's going to have a chance to do this, but if you can, if you get that R script installed, please try to make some of the simple delta climate scenarios using your main station, the best kind of historical variable, or the historical observations you can. If you don't have that yet, feel free to use Ames, Iowa, and play around with that. That was included in the package. Try to make it for all the 20 GCMs that are currently there for this RCP 8.5 and the 2040 to 2069 period. And then also, please try to make the simple M&V climate scenarios. These are scenarios with mean and variability shifts, which are going to be the basis for phase 2. So please try to do that for all 20 GCMs. And if you can do that, then you can give us much better feedback, in the next webinar and in the future. Let's see. So let's see. Loads of questions about slide 25. Okay. Yeah, Olivier, feel free to send me questions, and we can talk about that. And if you want to set up a phone call or something, we can talk about that more. All right. The only other thing I wanted to mention, this is the last slide here, is the next webinar is June 9th. In that webinar, we're going to talk more about working with your data. How do we actually do the quality assessment and quality control, and how do we generate the future scenarios? That's the kind of technical side. But then we're also going to focus on analysis. We're going to look at historical trends, look at the variability and association with major modes of variability. So we're curious, people in this project need to have a better understanding of how, El Nino and other major modes of variability, like, Madden Julian or other things, might be affecting their crops in the region. So if we can start to understand that, that will give us better insight into why a particular year may have had bad results, and whether that's something we can expect to happen more frequently. We're also going to look a lot more at the climate impacts on yield using the historical data, especially if we can find historical climate extremes and see how they affected the crops. We're going to look at climate change uncertainty and examine the projected shifts in extreme events using key agroclimatic metrics. And then finally, if there are people who are interested in more complex scenarios, I want to have some time in the next webinar to talk about that. And there's a lot of potential for that. There's Sonali's been doing a lot of work looking at monsoons in particular and how monsoons might change. We've been doing some work here at GIS with myself and Matthew Fulakeza, who many of you will meet soon, and we're looking at near-term climate scenarios and the variability that will interact with mean climate change in the next 20 to 30 years. And then there's also, of course, especially in Africa, a lot of results already from Cordex that we can start to integrate. And this is actually something I want to follow up with Olivier in the other direction here, which is how can we get better access to Cordex data, both for Africa and South Asia. I'm picking on Olivier because he sits a couple offices away from several of the people working on Cordex. So that's something that I think would be very useful if we could do that. If for nothing else, it gives us more dots in terms of projected GCM and RCM changes that we can impose and understand using our sensitivity tests, how we would expect those to affect future. So that's where we are here. I appreciate everybody who stuck all the way through, an hour and 7 minutes. Let's take a couple minutes if there are questions. And those who are on the phone call or watching this in recording, please always feel free to get in touch with me and Sonali with questions. But if nothing else, please start some of this work, because if we get to Victoria Falls and people are just beginning, we'll lose a day or two just bringing people back up to where we could be when we show up. All right, so let's see. Sonali, could I invite you to the microphone for a second to say a couple words and let me know if I've missed any questions in the chat. Are you there, Sonali, or muted?
Wait, can you hear me?
Yes.
Oh, okay, great. Yeah, I think I was muted. No, I don't have too much more to add, although I think, with Olivier's concerns, and Patricia had just commented as well, too, so it seems that a lot more clarification is needed on 25, and I think, Alex and I are well aware that that's, one of the newer procedures we're going to be undertaking, and so the idea Sherry had suggested of starting a blog or perhaps a climate forum, because I think it would be, of course, good and totally needed to have the teams offer comments on the methodology as well. As Alex had explained, we were looking to really understand the extent of the model projections, right, the variability, the uncertainty there. And if there are ideas, I suppose, too, we should be open to receiving those on that method. And so I'm not sure if a blog post is great because we can post answers to questions that Olivier or other people might have, but actually providing some system for feedback in a way that, is sort of transparent and everyone could see that would be good too. But overall, and then, we're just going to be working on this and putting this together leading up to Victoria Falls. And, please feel free also to reach out to us if you have problems installing and using the R scripts as well. So I think most people have that. For the new people, here, where, you know, as Alex said, I think it's going to be super important that we get into the analyses, particularly in the historical context at Vic Falls. So if you do run into any issues, do feel free to email both of us. One of us can respond to make sure that we get everybody up to speed by the time we get there. But other than that, I don't have too many more comments, but we might want to quickly talk about how to coordinate question and answer in the weeks leading up.
Great. And I think what we should do is we should have some back and forth on slide 25. If anybody wants to send some emails, I'll just remind people what slide 25 was. It's this one. Yeah, I'd be happy to have a discussion on that. And I like Shari's idea of having a blog. Maybe I don't know if we could do public comments on that or what, but at the very least, we'll put a blog post up and email. You can email comments in. I think this would make a very nice little white paper that we should probably try to write up, Sonalia, at least you and I, just to describe this approach and invite feedback on that. And hearing the feedback today, I think this will be a much more prominent part of our next webinar, just so people can understand that. So on June 9th, if you haven't seen anything before then, that would be a time to kind of get the full update of what's happening. And yes, we are very much encouraging feedback, and if there's a better way to do it, let's figure it out now before everybody goes all the way into all of these analyses. I saw a note also from Mary, and in terms of the R scripts, if you did them in phase 1 and you have them already installed, you don't need to reinstall. They are the same scripts. The only one I'm not sure about is the AgMIP to metrics. You might want to reinstall that one, but that would be as simple as just copying the one in the zip file that I just sent out into your own location. We will soon release new versions of those R scripts that will be methodologically the same, but will have a couple added features. So again, there's no reason to toss your old scenarios or your old scripts, but what you can look forward to is scenarios that will allow more GCMs to be incorporated as well. And thank you, Mary. Mary, it seems like there's some support in terms of selecting the models, and we can go from there. Let's see. Yeah, the other thing maybe just to mention on this slide 25, I'm getting ahead of myself here, but what you see here is the whole year. If we were doing this for maize production in Embu, Kenya, we would pick just that growing season and look at that. So that's another way we're going to be able to zoom in on some of this information. Any last comments, questions, or concerns? All right. So Seydou asked a question about whether the AgMIP to metrics script is truly working. I'm not sure when you say the version you had did not work well when you got that one, but I would try using the one that I just sent around in the zip file. Let me know about that. And then also try using that addendum that I just attached. Hopefully that will answer your questions and have kind of a go-to step-through guide of how to use that. So again, please try that out, send us feedback, and we'll try to address, if we hear that there's problems, we'll try to address that in the next webinar. All right, great. Now the other thing, if you are new, if you were not part of phase 1, and especially if you were not part of phase 1 and you are the main climate person for your project in phase 2, please not just feel free, please do send me an email. I would love to get to know you, talk you through some of this, and probably it would be in everybody's best interest if we could set up a short call just so that I can get you up to speed and answer any questions that you might have. So I think I know all the people who are doing this work, but if you're new and are the point person for climate for your regional research team, please get in touch. All right, thanks everybody. I don't see any last questions. Send me an email if you think of one just after we hang up. Have a great day, everybody. Thanks for staying up late in South Asia, and we'll talk soon. Goodbye.